We are now recording. Let's go from the current slide. And any questions on anything so far? Now, I asked the last class this, and no one had heard anything. Have y'all heard or read on the email anything about student course evaluations?
I got a thing recently, but it was for
elections.
SGA voting.
Right.
I got that, and I had 2 evaluations, but they weren't for this class. They were for my mini-term classes.
Oh, really? Was it online or? Okay, no.
They were at the Birmingham campus.
Okay, but it was about student course evaluations for second mini-term. Is that right?
First mini-term.
Oh, first mini-term, yeah.
They were
Yeah, you had that a while back.
Yeah.
Or was that recent?
It just pulled up for me.
Really?
But I don't know if I just didn't see it before.
Yeah, no. That means they were very late getting them out for first mini-term, which is not good. Some of those students may even be gone by now. But second mini-term and full-term classes, they should have opened student course evaluations already. So I'll see if I hadn't seen anything, but I thought maybe I just missed it. But and they don't always send to faculty what they send to students. But I thought surely we should have opened these by now. Yeah. So anyway, we'll check them.
I don't got them either.
Huh?
I don't got them either. But I did get my first mini-term history class.
And you did that one already. Good. Okay.
Yeah.
Well, hopefully keep watching because they should open those pretty soon. I think they should have already been open by now, but that's just my opinion. All right, so we're going to start Chapter 6, which is additional topics in trigonometry. There are 6 sections here. I doubt if we'll get all 6 of them done. We just don't have enough time. But let's get started where we can. And the first of these is the law of sines, a very handy-dandy little device that you can help solve triangles. And the thing is, all the triangles we've dealt with so far have been right triangles. But you guess what? Most triangles aren't right triangles. They are non-right triangles, and the other name for that is called an oblique triangle, one that is not a right triangle. Now, it could be oblique in the sense that all 3 angles are acute, or it could be that one angle is obtuse and the other 2 are acute. But they're just not right triangles. So our objectives and actually this extends a little way. Well, no, okay. We'll use the law of sines to solve oblique triangles when we're given 2 angles and a side or an angle, side, angle. Well, guess what? Both of those are 2 angles and a side, okay? And we can always use the law of sines when we have that situation. Now, there is one other. We can use the law of sines to solve oblique triangles when you're given 2 sides and an angle outside those, okay? Now, we always refer to that as SSA. We never refer to it the other way. Never mind. Okay, so then we'll find the areas of oblique triangles, okay, using something that looks a lot like the law of sines. And then finally, we'll use the law of sines to model and solve some real-life type problems. So the law of sines, you'll see, is a very useful, handy, and a fairly simple device or technique to use. So, introduction here. We already did the first part of the introduction. They mentioned what an oblique triangle is. In this section, and in the next, we'll solve oblique triangles. Those are triangles that have no right angles. That one happens to be all 3 of those angles, A, B, and C, are acute angles, meaning less than 90 degrees. The biggest one's A, but it's not quite a 90 degrees. B and C are smaller yet, so they're all 3 acute. And here's our convention. I think we've already used this some before, but in case you've forgotten. In these, we're going to name our angles capital letters and name our sides, the length of the sides, the smaller letters, lowercase letters. Now, notice the letters do correspond. And it doesn't matter which one you name which, but let's say this capital letter A representing this angle here, The side opposite that is little a. Okay? Capital letter B here is this angle here. The side opposite it is little b. And, of course, then the capital letter A represents the size of that angle, C, and the side opposite that is little letter C. The length of that side is little c. To solve an oblique triangle, we need to know the measure of at least one side and any two measures of other measures of the triangle. Either two sides, two angles, or an angle in the side. But you always need at least one side. Okay? And here's why. If all you had was the three angles, you could take that triangle and reduce it or expand it. Keeping the angles the same, there's no way to solve that. Okay? But if you know at least one size, that means you can't reduce or expand it without changing the triangle. Okay? So you need to know at least one side, and then either two more sides. Can't do the law of sines with that, but you can use the law of cosines. Two angles, always use the law of sines with two angles, or one angle and one side. If you know one side and you know one angle and one side, sometimes you can use law of sines, sometimes you have to use law of cosines. We'll get to that later. Okay? And here's a breakdown of what we were talking about before. Now this covers both this section and next section. This breaks down from the following four cases. If you know two angles in any side, and then again that can be angle side angle, angle side or angle side angle. If you know two angles, you use the law of sines. Okay? Two sides and the angle opposite. Okay? In this situation, you can use the law of sines. Okay? Three sides, you cannot use the law of sines. Okay? Two sides, if they're included angle, angle side, cannot use the law of sines there either. You have to use law of cosines. So the first two cases, these two here, angle side, or angle side angle, and side angle, you can use the law of sines. The last two, 3 and 4, you've got to use the law of cosine. That's in the next section, 6.2. Okay? So, here is the law of sines. Now this is why it works. This is a description of it. Okay? Now the actual law of sines is this. If A, B, and C is a triangle, an oblique triangle, okay, with the sides little a, little b, and little c that correspond, then the law of sines is, and you can write this in either like this or like this, little a over sine A is the same ratio as little b over sine b, and that's the same ratio, both of them are, as little c over sine c. Okay? And when you have two ratios equal to each other, you have a proportion. You can always solve a proportion. Okay? Now here is a real quick and dirty of why this is true. If this is an oblique triangle where your big angle is acute, still acute, or the big angle is obtuse, both of these will work, okay? Then let's just take, and it doesn't matter which one, but let's just take angle A here. And what you're going to do is look at the ratio. Well, take the angle A, drop a perpendicular from C down to the line that connects A and B. Okay? Drop a perpendicular. Either for the acute angle or the obtuse angle. Either one. Okay, the height of this triangle is H. Okay? And they indicate these both being the same. They don't have to be, but they could be. Now, here's something to note. What is H? Okay? In terms of A and B. Okay? Just in terms of angle A and side B. Well, guess what? For angle A here, this is now a right triangle because that's perpendicular, right? Okay? Well, H, the sine of A is H over B, because this now becomes the hypotenuse of that right triangle, right? Right angle, right? So, the sine of A is H over B, right? So let's write that down. Sine of A is H over B. Oh, let's get my color back. Sine of angle capital A is H over B. Which, let's solve that for H, and that gives us multiply both sides by B. The B's go out here, and you have H is equal to B sine A. Agreed? Okay. With that same construction here, notice that the sine of B, capital B here, is H over A, right? So sine of B is H over A. Capital B is H over little a. And then multiply both sides by A, solving for H. And now what you have is H is equal to A sine B. Right? Now those are the same H's. That's the same triangle. Same height. Nothing has changed, right? So you can set those two H's equal to each other. And that would produce B sine A is equal to A sine B. Right? And then what you could do is divide this side by sine B and this side by sine A. But if you just divide one side by sine B, you have to divide both sides by sine B. I can't write. If you divide this side by sine A, you have to divide this one by sine A. Okay? Well, here the sine A's go out, and you have B over sine B is equal, here the sine B's go out, A over sine A. Ha! That's the first part of the law of sines. Okay? Now, if you did, oh, and by the way, the same thing works for this one. Here's your right angle here, and this is a little trickier because here is your angle A here, right? And what is the sine of that angle there? Well, that's the sine of its reference angle, which is this angle here. And that's also B over A. And this would be, the sine of this angle would be H over B, just like the sine of this angle would be H over B, and the sine of this angle would be H over A. So it comes out the same way. Okay. Now, all you have to do is do the same thing, drop a perpendicular this way or this way, it doesn't matter which way. You come up with another two ratios that look just like this, only they will be A over sine A and C over sine C, or B over sine B and C over sine B, C. They're going to be the same. So all three of those are the same. Now, yeah.
Top part, how do you, like after you put them equal to each other, would you divide that up? Would you get it to?
Say that one more time.
Like after you put the two H's equal to each other on like the top right part?
Yeah.
What do you do? What do you divide that?
Okay, sorry. I did two at once, okay? We had here that H was A sine B and also B sine A. So I put those equal to each other, right? Okay, now it doesn't matter where you do. You can first divide this by sine A, then also divide that by sine A, not by sine B, okay? So this would give you B is equal to A sine B over sine A, okay? But then divide both of those by sine B, and this would be B over sine B is equal to A over sine A. Because the sine A's cancel out here, the sine B's cancel out there. So you get this ratio, and then you multiply, yeah, and this ratio is exactly the first two here. That proportion is the same. And then just drop a different perpendicular. It won't be the same H, but it'll be the same number for both of them, and you find out those ratios are the same too. B over sine B equal to C over sine C. And And there also, if you dropped them this way, that would be little a over sine A, it would be little c over sine C. Yeah, and they're always the same. Now, here's the other real nice thing with this. If those ratios are the same, then you can flip them all, and those ratios are the same. So whichever way you want to write it, it's okay. Just be sure you keep the sine A with little a, sine B with little b, and sine C with little c. And that ratio, whichever way you write it, has got to be equal when the others are written in the same direction. They work. Now, here's what this tells you. In order for the law of sines to work, you have to know at least one angle and its opposite side. That's all that's required for it to work. Okay? So if they give you angle A and sine A, you can always use the law of sines. Or angle B and sine B, you can always use the law of sines. Angle C and sine C. Once you set it up, you can solve the whole triangle with it. Now, if you know two angles, guess what you know? The third angle. Okay? So if you know any two angles and one side, that's fine. You know the third angle, and then you have a ratio that works. That's why side-side angle works. Because, I'm sorry. Yeah, the reason side-side angle works, if you know a side, and an angle, you know the opposite side. Okay? If you know angle, side, angle, so you know this angle, this side, and that angle, you don't know the opposite side. Yes, you do, because you know the third angle, and you already were given that side. Here's what won't work, though. If you have side, angle, side, there's no way you can get this side to match that angle. So then you have to use law of cosine. Or three sides, you have to use law of cosine. So law of sines work if you know a side and an angle and its opposite side. If you know that ratio, law of sines will also always work. Okay? So let's see how to apply it. Here's a triangle, okay, given in figure 6.1. Angle C, big old angle, greater than 90, and obtuse angle, but it still is an oblique triangle, okay? I get those two things crossed up sometimes. Oblique meaning not 90, obtuse meaning greater than 90, okay? You know another angle, B, and you know the side B. Guess what? I know law of sines is going to work. I know it, okay? Because you know an angle and its opposite side. Guaranteed, okay? Said find the remaining angle and the two sides, okay? Now, which of those things they ask for, remaining angle and the other two sides, is going to be easiest to get? The other angle, isn't it? Okay? So let's go on and get that first. What is that remaining angle? How do we get it? Okay, yeah, start with 180, subtract the sum of those two. The sum of those two is 131, right? Subtract that from 180, and you get 49, I think. Do you agree? Okay, 49 degrees. That was easy. If you know two angles of a triangle, you know the third angle. Always. Okay. Now, to get the other two sides, we're still missing A and C. How would you suggest we go about getting either one of those? You choose, I don't care which one. Second? Law of sines. And how do you want to write it? A little louder.
28.
Oh, 28. So that's B. So 28, and that is feet, so I'm going to put down over what? Sine of 29 degrees is equal to A, little a, we don't know, over sine of 49 degrees. Okay. Now, how do we solve that? Yeah, what they call cross multiplication, which you can use anytime you have a proportion. Two ratios equal to each other. The product of the means equals the product of the extremes. So I like to write it down this way first. A times the sine of 29 degrees is equal to 28 times the sine of 49 degrees. Okay? Now, frankly, I like to go on and divide. We're looking for A, so let's divide both sides by 29 degrees. Sine of 29 degrees. Okay? And the rest is history. Okay? You just plug in the numbers. Okay? 28 times the sine of 49. You can do that on your calculator, right? Now be sure you're in degree mode. Okay, that's the most important thing to remember, because if you're in radian mode, you're going to get wrong answers. Okay? Be sure you're in degree mode. So 28 times the sine of 49 degrees, divide that answer by the sine of 29 degrees. What does that give you A to B? Okay. Now the book carries it to huge things. You said 43.5, is that what you said? So let's just round that to 44. 44 feet, sorry. Duh. Is that what yours rounded to? Okay. I can't get my eraser to work. Okay. Round it to 44 feet. The book carries more digits than I do, but the thing is, if this is two significant digits, that's 3, but this is 2, that can only be 2, and in my mind, that can only be 2. Okay. Now, I like to do a little timeout here. Okay. And what the timeout is to just see if the answer is even beginning to make sense. And here's what I mean by that. We know that this is the smallest of the 3 angles. So this should be the shortest of the 3 sides, because that's the side opposite the smallest angle. And this is the medium angle, which is bigger than that one, so the side should be bigger than this one. And sure enough it is. That doesn't tell you got the right answer, but at least it tells you you don't have a stupid answer. I mean, if you came out with A being less than 28, you know it's wrong if angle B is less than angle A. That at least tells you're in the right ballpark. Okay, you're not completely out for it. Okay, what do we do next? Yeah, I got to find the other one. And what I suggest here is always use the ratio they give you. You could now say 44 is the sine of 49, but that's a round off. Remember, this one we assume they gave it to us correctly. We could have made an error in the other one, so always use the one they gave you. So that would be, start again with 28 over the sine of 29 degrees. Okay? And that now should be the ratio of C to sine of 102 degrees. Okay? Always keep lengths and sines corresponding to each other. Okay? And again, I like to go on and do my cross multiplication. Oh, now it started doing it again. Started this yesterday. That even if I'm close to the screen, well, it's not doing it as badly as it did yesterday. Before, if I got close to the screen, it started writing. You know, whether I wanted it to write or not. That's wrong. Let me see if I can erase that and we'll be through with it. And it erased everything, okay? Because it never literally picked up. Okay, still did a little bit, but not as bad. So I like to do the C times the sine of 29 degrees is equal to 28 times the sine of 102. Okay? And then solve for the thing we're looking for, which means divide both sides by sine 29 degrees. And these go away, and that gives you what C is. And if you punch that in, 28 times the sine of 102 divided by the sine of 29. Say that again.
56.49.
Okay, so let's just call it 56. So that will be about 56 feet. Okay, I bet you the book does the .49. I'm not going to, because you can't get more precision out of the problem than you put into it. So you can't get that to nearest hundredth of a foot if all you're given is the nearest foot. It just doesn't work in physics that way, so it shouldn't work in math that way either. So let's see. Oh, and let's just check qualitatively and see if what we got is right. If this is the largest angle, that should be the largest size, and sure enough it is. So we feel nice, warm, and fuzzy about it. Okay. All right. I'm going to erase my trick and scratch if that's okay with you. Okay. And let's see what the book did. Okay. The third angle is the easiest thing to get first. Subtract from 180 the sum of the other two. They subtracted them separately. However you do it, that came up to 49. Good. Okay. Then by the law of sines, the A over sine A is the same as B over sine B, is the same as C over sine C. We know in any single one of those equalities, we can get 3 out of the 4. And if you got that, you can find the fourth. So we start with this one, and now they do it a little differently, which works just as well. I like my way better, but you know, this is just as good. Since you're solving for A, we see that it's the ratio, because A over sine A is B over sine B, those are equal, multiply both sides by sine A, that works very nicely too, okay? Okay. So then you have A is equal to that, so it's B times sine A. I like to write those together. They like to write it offside. It doesn't matter. Divided by sine B, which is exactly what we did. That's 28 over sine of 29 times sine of 49. We did 28 times the sine of 49 divided by sine of 29. It works the same way, okay? And that gives you 43.59 feet. Well, in my mind, you can't get more precision out of the problem than you put in. I rounded that to 44. Fine. I'll accept either of those answers, okay? And then we did the same thing here, because the ratio of C to sine C is the same as B to sine B. Multiply both sides by sine C and you get the same thing. So B over sine B is the same, 28 over sine 29 times the sine of 102, and that gives you 56.49 feet, which to me rounds to 56. Because you can't get more precision out than you put in. All right, that was example 1. What they do is skip example 2. So let me see if I can do example 2 on this slide. All right. A pole tips toward the sun. Now, there's no reason for a pole to tip toward the sun. They're just giving you that because that works in this problem. Tilts toward the sun at an angle of 8 degrees from the vertical. Okay, so here's your pole here. Here's the vertical. Here's the soil. And the pole is now tipping this way. I probably exaggerated. This is 8 degrees from vertical toward the sun. Okay, now the reason it has to be toward the sun, it casts a 22-foot shadow. Well, if it's toward the sun's over here somewhere, okay, it's tilting toward that, then its shadow is going to be over here somewhere, okay? And this is a 22-foot shadow. If that were anywhere else, then the tilt would not be in the same plane as the sun, so you wouldn't be able to do the problem. But if it's tilting toward the sun, the angle and the shadow and the pole and everything are in the same plane. Okay. The angle of elevation from the tip of the shadow, so you're standing down here, to the top of the pole, you're standing down there and you have a sextant, and you find that to be 43 degrees. Okay? The question is, how tall is the pole? What is the height of the pole? Okay? Now, do we have enough information to do this problem? Okay. Now, we know this angle. Now we know this angle, which is not one of the angles of the triangle. But what does that give us? That, yeah, 90 plus 8 will give us the angle down here. What is 90 plus 8? Pretty hard. 98 degrees. So we do know two angles. This is 98 degrees. Okay? And we're looking for this, the height of the pole. Okay? Now I know what the book does. It names each of the angles and then corresponding sides. Do you want to do that, or do you want to just do it from what we see here? Okay. So what would be the obvious thing that we know? What we're looking for is this side here. And we know the angle opposite that side, but that's not going to help us. We got to know a ratio. We know this angle here, but we sure don't know that side. So we don't have a ratio yet. But what will give us a ratio? Second? Okay, how do you, yeah, you're going to use the law of sines, but you got to have a ratio first. And we don't have one just with what they've given us. Find the third angle, because you have two of the angles, you can certainly find the third. So what will that angle be?
39 plus subtracting.
Okay. 180 minus 98 and 43 would be 141, right? Right? If you add 98 and 43, I think you get 141, right?
Yeah.
And then that gives you 39 degrees. Perfect. So we do know this angle to be 39 degrees. Now that we know that, we know an angle and its opposite side. So we are all set to go for law of sines. And what formula are you interested in? There's three ratios that you could use. Which one do you want to use? You got to use the one you know, 39 and 22. And which other one might you use? The 43, because that's what you're looking for. Who cares what the side is? It's immaterial, not important. What you need is this one, so we use that. So that's what we'll use for the law of sines. You tell me what to write down. 22 is the sine of 39. Don't forget to put that in there. 39 degrees as B is what you want to call it? H, whatever. Yeah, well, you can call it anything you want to. You want to call it B? B is to sine of 43 degrees. Okay, and once you have it set up that way, just multiply both sides by sine of 48. So that'll give you B is equal to 22 times the sine of 48 degrees divided by the sine of 39 degrees. Plug and chug. You got a calculator, plug those values in, see what you get. 25.97. Let's just call that 26. 26-foot pole. Above ground. Okay? I'm just going to guess they buried it at least 4 feet. So it probably was a 30-foot pole. Maybe even greater. But, you know, they didn't ask that. How much was above ground? That's what they wanted. What's the height of the pole above the ground? So we'll say 20. I'm sorry, did I misunderstood? Oh, I wrote the wrong number down. How did I get a sine of 48? Oh, I misread my 3 there. That's why, my lousy writing. That can cause all sorts of problems. That sine of 35 43 degrees, not 48 degrees. Sorry. Okay.
I was wondering where you got 48 from.
Oh, well, why don't you say something? Okay. Now, with the correct numbers in there, what do we get?
$23.84.
23.84. Let's just call that about 24 feet. About 24 feet. Now, again, this time I would say, I think they buried it 6 feet under and had a 30-foot pole. They should have put it down at least 6 feet, but if they did put it 6 feet, I'm wondering how in the world did it get the leaning 8 degrees off? Because usually that's, if you bury it that far, you're not going to have that much thing. But if there's a lot of tension on that, that can create the leaning. And that's why, if you see power poles where we have a place up at Smith Lake in Winston County, and the roads to get there just go like this, you know, all over the place. So the power lines are having to follow the roads kind of, and so there's lots of bends in them. Well, if you have a power line that's coming in this way and going out this way, that pole over time is going to lean because that's a lot of tension on it, unless you put a guy wire on the opposite side of it. So if that top would have been a guy wire, then you might could have straightened up that pole, okay, if you put enough tension on it. Okay. Usually it's better to plant it straight, put your guy wire in, and then that keeps it from bending. Leaning. Okay. So 24 feet is what I think. Okay. Now maybe it was only a 25-foot pole, and no wonder if you buried it 4 feet, it's going to lean. I mean, 1 foot, that's not enough for a power pole. All right, so there was example 2, sort of ran it into the ground. Okay, we've already done example 1, so let me. All right, of course, we could have an ambiguous case, and that's going to be our side-side angle, always set in that order, okay. Now, in example 1, we saw that 2 angles, one side, always determines a unique triangle. You can't miss out if you have 2 angles and a side. Even if the side is opposite one of those 2 angles, if you know 2 angles, you know the third angle. However, if you have 2 sides and 1 opposite angle given, there are 3 possible situations. Either you don't get any triangles at work, we'll look at that case, you get 1 and only 1 triangle that works, or you get 2 possible triangles that might both work and satisfy your initial conditions. So let's look at why this is the case. All right, that's gracious. I had treatment on Friday, and it seems like it's usually Tuesday when I start feeling it. I'm feeling like I'm just fatigued. I went down between classes and drank some soda to get a little caffeine. It's not helping. Okay, so here's the one. Now, here's the key. Remember back when we first did it, this thing about the height of the triangle, okay? Whatever, okay? Now, where h is b times the sine of a, the way we've drawn it here. If you know this angle, let's say, these 2 sides and that angle, we always say it that way, okay? All right, and that angle. Even though you know the side opposite the angle, if this A is too short, it's never going to make a triangle. Okay? So you can't just make any 3 numbers up, but if you do this, in other words, if your A is less than h, you're not going to get a triangle. Now that's with an acute angle A. Okay? So number of triangles possible? None. You can't get 1. Okay. Now, again, with A being an acute angle, if A is exactly equal to h, you have 1 and exactly 1 triangle, and guess what? That's also going to be a right triangle. Because if A is equal to h, That's the only place it's going to intersect. So you don't have an oblique triangle, you have a right triangle. But you do have a triangle, and it will work. Okay? Now, if A is acute, and A is greater than B, greater than or equal to B, then it's always going to work. Always! And you'll have one and only one triangle. That A can be anything you want it to. It just keeps going. Okay? So, everything so far is depending on the length of A. Well, let's do one more with A being oblique, acute triangle. Capital A being acute. If you have the A that's greater than H, see if it's equal to H you have one right triangle, less than H you don't have anything. But A greater than H but less than B, then you have this to me is really the ambiguous case. You can have this triangle here or that triangle there. They both are going to work with the given information. See, all we do was little a, little b, and A. With that, you could have your angle over here or the angle here. You just don't know. So that is the ambiguous case. Now, if A is an obtuse triangle, you don't even care what H is. If A is less than B, then nothing's going to work. It will not ever work. Okay? And I want to say, okay. Yeah. If A is less than, if that's an obtuse triangle, if A is less than B, you'll never get that to work. Because you see, if A is an obtuse triangle, little a's got to be your longest side. So it can't be shorter than B. It's got to be the longest side. Okay? So that you won't get. It's just like here. It's never going to work. Okay? But if A is greater than B, any amount greater than B, it'll always work. And you only have one. You can't have an ambiguous case like this because it can't swing back and forth, not with A being obtuse. It's fixed. So if A is an obtuse angle, it will always give you one correct solution. A is greater than B. The length of side A is greater than side B. If A is shorter than B, it will never work. It's when it's an acute angle, then you have several cases. The A has to be greater than or equal to H, equal to H or greater than H. That will be, well, okay. If it's less than H, it's never going to work, okay? If it's equal to H, you'll get 1. Greater than H, but less than B, you could get 1 or 2. But if A is greater than B, it's going to be 1 and 1 only. Okay. So, there's what you have to contend with. Now, let's see the example. Example 3. Here's a triangle. Little a is 22 inches. Little b is 12 inches. And capital A is 42 degrees. Okay? Now this is a side-side angle. All right? And your A is acute. But as long as little a is greater than B, it always will work. You'll have one and only one solution. No ambiguity here at all. So let's find the remaining side and angles. Where do you begin on this one? Okay, start with A's because you have both the angle and the side. Yeah, that's the place to begin. And which way you want to write it, I don't care too much. Okay, you're going to do little a over sine of A. If you know that ratio, that's a good place to start. So that would be 22 inches over the sine of 42 degrees. Okay, and that's going to be what?
Equal B over sine.
Okay, and you know B to be 12 inches over the sine of B. All right. You know 3 out of the 4, so you can solve for sine B. That's what I'm going to do, sine B from the cross multiplication here. Now here's how I do it because I'm really lazy. I could write down that product and stuff, but I always write what I know on top. Okay, the ratio you know both parts of on top, and that would be 12 times the sine of 42, your cross multiplication that you know, and divide by the one that you don't know one piece of, 22 inches. Okay? So, plug it in, plug it in. 12 times the sine of 42 degrees. Make sure you're in degree mode. Divide that by 22 inches, or 22. And that should give you what kind of numbers? Better give you a number less than 1. Right? Why? And can't be negative either, folks, okay? Because the sine of B is always between -1 and +1. We don't have any negatives here, so it's between 0 and 1. Does that give you a ratio between 0 and 1?
Yeah, 0.36.
0.36. Okay, now use all the digits you want to there, because the next thing you're going to do, I'll write down what you said, that sine of B is equal to 0.36. But I would leave every one of those digits in your calculator, okay, and then do an inverse sine of that. Inverse sine of this, that's supposed to be a B, not a beta, okay, is equal to the inverse sine of 0.36. But I would do all your digits in there. That's the inverse sine. And this, of course, sine of a inverse, or inverse of a sine, would be B. And be sure you're in degree mode. When you do the inverse there, what do you get?
21.4.
Second? 21.4. 21.4 degrees. Let's just round that to 21 degrees. Okay, because they don't give it 42. Now, let's pause here and see if this makes sense. Okay? Now, we can't tell any more than looking at it, but if this is 42 degrees, and C obviously appears to be obtuse, then B looks like it's the smallest angle, so sure enough, 21 degrees is less than 42. And it better be less than C2, okay? So that at least is feeling it. Oh, yeah, like, time out. We knew that had to be the case. Because if you know this is 12, that's 22, B's got to be less than 40. Yeah, we know that. We didn't have to guess anything. B had better be less than 42 degrees. It was. Doesn't tell you whether it's right or not, but at least it tells you you're in the right ballpark. Okay, so we've gotten our B. Okay, we're still missing two things, capital C and little c. Now, which of those is the easiest or hardest to get? Is the easiest to get. How? Yeah, subtract the sum of these two, which is 63 from 180. And what does that give you? 117 degrees. Now, they probably are going to carry around some decimals, but I really don't think you can justify that. Let me go ahead and fill this in. This was 21 degrees approximately, and this is 117 degrees approximately. Okay? So now we got 5 out of 6. We still don't know little c. How are we going to get that? Yeah, good old law of sine should do it for us. Now, which would you use? Yes, use the A's because you know those are correct. You may have made a mistake somewhere or round off error or anything else, but they gave you A that better be correct. So you got 22 over sine of 42 degrees is equal to little c over the sine of 117, right? Okay. So what is little c? It's the product you know, 22 times the sine of 117 degrees divided by the sine of 42 degrees. Goodness gracious. Eyes are stinging like crazy. All right. Plugging and chugging, what do you get? A little louder. 29.29, let's just call it 29 inches. Okay? And again, you stop and ask yourself, is this making sense? Well, it better be the longest of the two sides. This is 12 and 22. 29 is certainly longer. Almost doesn't seem like it's long enough, but then when you look at the picture, it's not that much longer than A's, but it is longer than A. That's a little shrimp here. You know, so, yeah, it is. So sure enough, that feels good. Let's see what they got. Can I go on and erase mine? The thing you had to do here was take an inverse sine to get what angle B was, and you did that well. Okay, let me erase this. And they started with the law of sines. They knew the ratio of A to sine A. Well, I would have written that first, but they wrote it second. Okay, so sine B, and here's why they wanted to do it that way, multiply B times that ratio, which is exactly what we did. I just wrote B sine A over A. And that gives you 12 times the sine of 42 divided by 22, which gives you, and they said about 21.41, which I say is about 21, because how do you get more precision out than you were given in? I don't know. Okay? Now determine the third angle, capital C, 180 minus 42 minus 21, and that would be, they say 116.59, I say 117, okay? Because how do you get more precision out than you put in? I don't understand how you could. So 117, so then the remaining side is use the ratio you know, A to sine A, and that has to be C to sine C. You know angle C now. So multiply, and you get little cb, the ratio. And again, I like to do A times sine C divided by sine A. And that gives you 29.40, which is 29 inches. Okay, good deal. Now, why in the world, when you have these ambiguous situations, do you do the one that is easy to do and then not show you how to do the ones that are not so simple? Okay? So let's back up and do example 4. Oh my word, I am so tired. I'm so sorry. Show that there is no triangle for which A is equal to 15 feet. Little a is equal to 15 feet. Little b is equal to 25 feet. And angle A is equal to 85 degrees. Okay. Now, here is my first gut reaction to this. This angle A is awful close to 90. Okay? So, if that's awfully close to 90, then this side A is probably awful close to your hypotenuse. If that's hypotenuse or close to the hypotenuse, it doesn't look like any way that's going to happen. You might say, well, but B could be a slightly bigger angle, and that would leave C being in a really tiny angle. I still don't think that would work. But how do we do this? Mathematically, how do you show it can't possibly work? Use the law of sines. What do we know here? What ratio? That 15 is to the sine of 85. Okay, that's A and A, 85 degrees. And that has to equal, get out of there. I'm sorry, I got it. Poor people at home didn't know that was coming, did they? Okay. Is equal to B over the sine of B. That's got to be true. Yeah, I'm sorry. Ooh. If that's a legitimate triangle, that's going to have to be true, right? And we know what little b is. That's 25. So let me go on and make that substitution there. Thank you. I don't know where this is coming from, but it's miserable. Okay. So, we know 3 out of 4. Let's solve for the one we don't know. So your sine B is going to be equal to the ratio you know, or the cross product you know, 25 times the sine of 85 degrees divided by 15. Okay. Sorry. All that sneezing has now loosened everything up. I may have to go down the hall. I hope not. All right. Punch it in and see what you get.
About 1.66.
1.66. Is that a good thing for the sine of B to be? No way. Because the sine of any angle is going to be between -1 and +1. And since we're not dealing with negatives, it's between 0 and +1. That's way outside 0 to +1. Can't happen. B would be undefined. Just cannot happen. So if you do trudge through a problem and come up with something impossible like this, you may be in the never happen case, okay? And that would be this one. No solution case. All right. All right, there is a checkpoint there, well worth your effort. The picture, the illustration there shows you why this can't ever be. And let's move on to example 5, which again they don't show. So let me erase the ink. And sorry, I've got to run down the hall. My nose is now running like a fountain. I'll be right back. Let me put this on pause. I'm sorry. So let's look at example 5. Okay, we just did 4. Here's 5. Now, here's what they give us on this one. A is equal to 12 meters. B is equal to 31 meters. No. Okay. And capital A, angle A, is equal to 20.50 degrees. 20.50 degrees. Now, this time, they gave the angle in 4 digits. Unfortunately, I only gave the lengths in 2 digits, so we'll see what we can do with this. Okay. Now, what we have is an acute angle A here. So what's required is that this A, even though it's less than B, that may still be okay, it's just got to be greater than H. And H is B times the sine of that angle. So if you will plug that in real quickly, 31 times the sine of 20.50 degree mode, and see if that's something less than 12. It's going to be tight. Oh, it is. Good.
10.8.
Huh?
10.8.
10.8. Okay. So that means, but then that is less than B. I mean, A is less than B, but greater than H. So this is going to be the really ambiguous case. You could have two possible situations here. All right, so where we have to go, where would you begin then? Okay, did I hear 12? The ratio you know is 12 to the sine of 20.50. Okay, seems a strange thing to do, but it's fine. And that's equal to the only thing we don't know, I mean, the other thing we know is 31 is to sine B. Okay, now, understand, I'm going to try to draw this triangle. I don't do a good job in this, but here's our baseline. We don't know where to terminate that. Here is angle A here is 20 point, get out of there, 20.5. So that's a very small angle, 20.50 degrees. I probably have it too big, okay? And this is our B here, 31 meters, okay? Now A, little a, is 12 meters. So it could be down here or it could be over there. That's the deal. The H you said was 8 point something, didn't you? Or 10 point something. 10, okay, yeah. So that's it. So here's our two possibilities, okay? This could be B over here or this could be B over here, okay? So we have two possible B's here. Let's complete what we don't know. This thing we don't know is sine of B, capital B, and that's equal to product that we do know, 31 times the sine of 20.50 divided by 12. Okay? Now, that's how I like to do it. Look, does it a slightly different way, but or it makes it look different, but it's the same type thing. Okay? What do you get sine B to be? 0.90. 0.90 anymore. Huh? 47, blah, 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 blah. Okay, we'll just, okay, let it run on and off somewhere there. Okay, now, if you were to take the inverse sine of this to give you B, it's automatically going to give you the acute angle B. It's not going to give you the obtuse angle B. So do the inverse sine and see what you get. 64.78. Okay, so one answer here, capital B, is 64.78, and we will allow that many because they gave it before degrees. So this will be this one, approximately 64.78 degrees. Okay? Now, you know that's got to be acute, so I put it there. All right. Now, remember, sine is positive in both the first and the second quadrant. And if you were in the second quadrant, then here is a 64.78. If you were to subtract that from 90, and let's do that. That would give you 25.21 degrees. No. Yeah, 25.21 degrees. Right? Now add that to 90 and you get the same thing on the other side. So that would be 115.21. So when you add these two together, you get 115.21 degrees. Okay? So you have two B's, okay? Or not two B's. I'm sorry. Do you want to call this B sub? How do you want to separate the two? Big B, little b? Okay. We'll call this big B. I'll call it B sub, no, this is B sub B, and this is B sub L. Big B and little b. Okay? Now, make sure I'm not doing anything stupid. 64.78, and the other is 115 point. I got 2-1 and they got 2-2. What did I do? I did something stupid, didn't I? Yeah. I did a 1 here. It's supposed to be a 2. I knew something wasn't looking right. So this would be 2-2. Okay. Not far off, but a little bit. And I subtracted it. Subtract very well. Okay. So, that's our situation. But that just gives us one other angle. Okay. We still don't know beans about C's. Either big C, little c, what I mean. All right. So, do you think it might help to have different colors here? Okay. What color do you want the other one to be? Say again? Red. Okay. All right. Let's make the big one red. Okay. So let's make this angle big B and make it the 115, 22 degrees. I guess I could have erased that first. Let's do that. Okay, that looks really bad. Okay. Big B is going to be 115.22 degrees. Okay. Now, let's start with our first triangle, the one with the little b. Okay. We now know, let's go back to that color. Okay. We know A, little b, capital B, and we knew this A here was 12. So this A is 12 meters. Okay? What we don't know is anything about either C. Okay? But it's easy to get angle C, isn't it? And once we get angle C, then that will give us the little c down here, which is going to be our long C, because that angle C is going to be bigger than our other angle C. Okay? So, which is it? Did we say it was easier to get there? Angle C or point C? Angle, because all you have to do is add these two angles together, subtract from 180 and get that one. So let's do that. The sum of those two would be 90, that is a, no, that's a 4. I can't read my writing. 85.28. Okay? 85.28, and subtract that from 180.00. And that gives you 94.72. So this one is 94.72 degrees. Got it. Okay? Okay. Now that we know that, what can we do? Say again? I can't hear. Law of sines, is that what you said? Yes. Okay. And the law of sines here, using the angles and the ratio you know, is that 12 is to the sine of 20.50 degrees, And now we know we're looking for little c, and that's to the ratio of sine of 94.72 degrees. Okay, so what we're looking for is little c then, and that little c is going to be the product we know, 12 times the sine of 94.72 degrees divided by the sine of 20.50 degrees. So you punch that in your calculator and see what you get. Okay, let's say 34 point what? 14? Okay, let's just say 34 meters, because they're meters. So this is about 34 meters. Well, does that make sense? Well, we know this is our small angle, 12. This is our medium angle, 64.78, and that's the medium length. This is our bigger angle up here, so that better be the bigger side. Sure enough, at least the relative sizes are right. Okay? So we've got the first triangle, and that would be actually slightly obtuse triangle. It's oblique, but it's slightly obtuse because C is a little bit more than 90. My picture doesn't look like it, but I said I had 20 too big, so I didn't have that. So anyway, lousy drawing. Don't count on the drawing. Okay. Now we have to start over again and do the other angle B, the big B, which is 115.22 degrees. Okay? So I'm going to change to Sarah's red. Okay? And we got to do everything that we just did over again, but now using this. So now we're going to be doing this. So basically, we're going to do this for big B. So this will produce sine of big B. Wait a minute. Sorry, we've already done that. I'm all over the board here, and I can't figure out where I am.
What?
I'm trying to see where we determine. Okay, I don't guess we need big B anymore. We already got that. We got little b. Sorry, we didn't need that. So, okay. We already got big B, so we didn't need anything there. What we got to do is get C from this now. So the C that corresponds to that B, this is going to be C. I'm going to put sub B just so it matches the B sub B, but understand this isn't a big C, this is a little c now, okay? Because look at that. There's what C is now. So what is that? We know A was 22.50, capital big B is 115.22. Add those two together, and you get 135.72. Right? Subtract that from 180.00, and you get 44.28 degrees. So our C sub B, which is not big anymore, this is 44.28 degrees. Okay, so this is the second case. All right, now to get the little c that corresponds to that, that's going to be this thing. We'll call that C sub B also, even though it's smaller than the other C. Now we do the ratio we just did here. Little c is 12 times the sine of, and this sine was my C, which is 44.28 divided by the sine of 20.50. Okay. Punch that in and see what you get. Are we running out of time? No. Oh, yeah, we're way past. Way past. Why didn't you stop me? Okay, sorry about that. With my break in the middle, I've completely lost track of time. 73? 23.92. 23.9. Well, let's just make it 24. 24 meters. That better be a small side because now this angle is bigger than A, so it's got to be more than 12, but it can't be as big as B, which is 31. Yeah, makes sense. All right, got that one done. Sorry about that. You should have stopped me. We'll start next time with area of an oblique triangle. And I did bring a pencil in, so let me make that mark. Okay, and homework exercises, you can do any of the odds 5 through, well, I do 5 or 7, those have pictures, and then any of the odds 9 through 21. All the odds are in calcchat.com, 11's in CalcView. Then do any of the odds 23 to 31, they're all at CalcChat, 29's at CalcView. And then do 33 or 35. They're both at CalcChat, 33's at CalcView. And we'll stop there and pick up from there next time. Sorry that I went over it like crazy. All right.
About how much?
20 minutes, almost.
20 minutes?
Yeah. It's now 11:03.
I need an excuse if you're going to do this.
Oh, I think they'll just tell them that you had a loudmouth instructor.
It's only 11.